Imagine walking into the gym without eating anything. No breakfast, no pre-workout energy drink, no protein bar on the way, just you, your body, and an empty stomach. For most people, the thought immediately triggers resistance. It feels wrong, unsafe, almost irresponsible. But here's the uncomfortable truth most people never stop to consider. The meal you eat right before a workout doesn't actually provide the energy for that workout. Not in the way you think. Today, I'm going to show you what really happens when you exercise while fasting, why your body becomes a fat-burning machine, and how this ancient survival mechanism can transform your metabolism in ways that eating before exercise could never. To understand why exercising while fasting is effective, you first need to understand how the body actually processes food. When you eat a meal before exercising, the food doesn't go straight into the muscles and suddenly become fuel. That's not how human digestion works. First is glycogen. Glycogen is simply glucose stored in the liver and muscles, and is the body's most convenient energy source. It's quick, efficient, and easily accessible. An average adult stores about 400 to 500 grams of glycogen, equivalent to about 600 to 0 calories of usable energy, depending on your activity level. This reserve can last from 12 to 24 hours. The second fuel source is body fat, and this is an important point to note. Even a relatively thin person stores tens of thousands of calories as fat. That's not reserve fuel, it's a huge reserve of energy. When you eat, food can sit in your stomach for 2 to 5 hours before being broken down enough to move into the small intestine. From there, nutrients are absorbed slowly over the next 4 to 12 hours. In other words, the calories from your pre-workout meal cannot be used during your workout. They are being processed for later use. So why do people feel more energetic after eating? Because the brain has prepared that energy. Hormones like insulin and dopamine shift to prepare for the upcoming calorie intake, creating a psychological and physiological readiness. This feeling is real, but it's not the same as usable energy. Imagine your body as a hybrid car. You have two fuel tanks, a small, convenient one containing stored blood sugar and glycogen, and a massive battery pack containing excess body fat. On average, each person stores about 500 to 2,000 calories as glycogen, but carries tens of thousands of calories as fat. When you eat constantly, you never learn how to utilize this enormous energy reserve. You become dependent on the small fuel tank. When you fast for 12 to 16 hours, your body's glycogen stores begin to deplete. They don't disappear completely, but they're no longer as abundant as before. And when glycogen becomes scarce, your body doesn't panic. It adapts. It switches to another fuel source. This is where exercising while fasting completely changes the game. With less glucose, metabolism is forced to use fat as an energy source. Fat cells begin releasing fatty acids into the bloodstream, and the liver converts some of that fat into ketones, an alternative fuel that muscles and the brain can use efficiently. This switching isn't extreme or unnatural. It's a normal biological response that humans have relied on for survival long before food became abundant. The ability to flexibly switch between burning glucose and burning fat is called metabolic flexibility. A healthy metabolism isn't limited to a single fuel source. It adapts based on available supply. But when you eat regularly throughout the day, especially refined carbohydrates, your body rarely needs to make that conversion. Over time, your body's ability to burn fat decreases, not because there's a problem, but because it was never needed. When the body is no longer supplied with so much glucose, a completely different internal environment forms. Insulin levels drop, and this is more important than most people realize. Insulin is not a fat-burning hormone. It is a storage hormone. When insulin levels are high, fat is locked tightly inside fat cells. When insulin levels are low, this locking mechanism is released, and fat becomes more accessible. During fasting exercise, no new glucose enters the bloodstream. Thus, insulin is suppressed. This allows significantly more fat to be released and used as energy. Numerous studies have shown that fasting aerobic exercise can increase fat oxidation by 20 to 30% compared to the same exercise performed after eating. At the same time, another powerful hormone also surges: growth hormone. Growth hormone plays two crucial roles. It signals fat cells to release stored energy and helps protect muscle tissue from breakdown. Fasting alone increases growth hormone. Exercise alone increases growth hormone. When both are combined, the effect is amplified. In some studies, growth hormone levels increased many times above baseline during fasting and exercise. This is one of the main reasons why many people are surprised to find they don't lose muscle mass when exercising while fasting. In fact, many people maintain or even improve muscle mass while losing fat. This is where the science gets interesting. When you exercise while fasting, you activate a key metabolic switch called the AMPK signaling pathway. AMPK stands for AMP activated protein kinase, and it's like the CEO of your cell's energy management system. When AMPK is activated, it initiates a series of beneficial adaptations. It increases the number and efficiency of mitochondria in cells, the energy factories that produce energy. It enhances insulin sensitivity, allowing cells to respond better to the insulin the body produces. It activates autophagy, the body's cellular cleansing process that removes damaged proteins and organelles. This AMPK activation only occurs when your cells sense an energy deficit. When you are adequately nourished, AMPK is in a dormant state. But when you exercise while fasting, you create a perfect storm of energy demand without a supply, forcing AMPK to awaken and optimize your entire metabolic system. As these hormonal changes occur, another important change also takes place in the brain. During fasting, the liver produces ketones from the breakdown of fats. Ketones cross the blood-brain barrier and provide a stable, efficient fuel source for the brain. Many people report feeling calmer, more alert, and more focused when exercising on an empty stomach. This isn't a placebo effect. Ketones are a better fuel for the brain. They burn more cleanly than glucose, creating less oxidative stress and providing more energy per molecule. Your brain actually functions better thanks to ketones than sugar. Fasting and exercise also increase a protein called BDNF, a brain-derived neurotrophic factor. Think of BDNF as fertilizer for your brain cells. It supports learning, memory, and brain resilience. Add to that an increase in norepinephrine, a neurotransmitter associated with alertness, and the mental shift begins to become apparent. Your brain is responding to a state it recognizes as meaningful and adaptive. For much of human history, food was not a guarantee. Our ancestors didn't wake up, eat breakfast, and then decide if they had enough energy to move. They woke up hungry and had to move first so they could eat later. One of the most profound effects of exercising while fasting occurs at the cellular level through a process called mitochondrial regulation. This is the body's quality control system for mitochondria, the energy-producing structures within cells. When you exercise while fasting, you force your mitochondria to work harder with a scarcer fuel source. Weak and inefficient mitochondria cannot keep up and are marked for destruction. Your body then creates new, more efficient mitochondria to replace them. This is like upgrading from an old, gas-guzzling car to a high-performance hybrid. Your cells become more efficient at producing energy from any available fuel source. This mitochondrial restructuring is one of the reasons why people who regularly exercise while fasting often report sustained energy improvements that last long after the workout ends. There's an evolutionary reason why all of this went so smoothly. For much of human history, food wasn't a guarantee. Our ancestors didn't wake up, eat breakfast, and then decide if they had enough energy to move. They woke up hungry and had to move first so they could eat later. Hunting, gathering, long journeys all happened while fasting. If the human body became weak, lethargic, or vulnerable to food scarcity, humanity would not survive it. The opposite trait has been selectively bred. Those who become more alert, focused, and capable when food is scarce are the ones who live long enough to pass on their genes. Your body remains programmed. It doesn't perceive short-term fasting as dangerous. It sees it as a signal to mobilize resources, enhance focus, and preserve what matters most. Fasting performance isn't a modern trick. It's an ancient characteristic. This is why many people report feeling like they're entering a predatory state during fasting training. Your nervous system activates the same pathways that helped your ancestors track prey over vast distances. You become more focused, more determined, more resilient. This isn't suffering. This is optimization. When you combine fasting with exercise, you create a beneficial state of stress called hormesis. This activates heat shock proteins, HSPs, which act as molecular repair teams that travel throughout the body to repair damaged proteins. Think of HSPs as a maintenance team that only operates when the building is empty. When you're constantly eating and your cells are busy processing nutrients, HSPs can't perform repair work effectively. But during fasting training, when cells focus on energy production instead of processing nutrients, HSPs can finally get to work. These proteins repair damaged cellular structures, refold misfolded proteins that can lead to disease, and help your cells adapt to stress more effectively. This is one reason why people who regularly exercise while fasting often show improved indicators of cellular health and longevity. As these hormonal changes occur, another important change also happens. Your insulin sensitivity improves significantly. Insulin sensitivity simply describes how efficiently your cells respond to insulin. When sensitivity is high, your body needs very little insulin to transport glucose into your muscles, where it can be used or stored. Exercising while fasting helps break the cycle of insulin resistance, a major problem in modern metabolism. When you exercise without eating, insulin levels are already low. Your muscles still need fuel, so they become more efficient at absorbing glucose from the blood with minimal insulin involvement. This improvement doesn't disappear when the workout ends. It can last for hours afterward, accumulating over time. Regularly exercising on an empty stomach essentially retrains your cells to respond better to insulin, improving metabolic health in ways that go far beyond the gym. Understanding that exercising while fasting is effective is one thing. Knowing how to apply it intelligently is what truly helps maintain its effectiveness. Not all activities demand the same amount of energy, and that difference is crucial when you haven't eaten anything. Low to moderate intensity aerobic exercise is often most effective when fasting. Activities such as brisk walking, light jogging, gentle cycling, or regular swimming rely heavily on fat for fuel. You can usually sustain these activities for extended periods without feeling exhausted. Even after many hours without eating, this is where most people should start. It allows your body to adapt without stress and build confidence instead of fear. Your body learns to use fat efficiently while your mind learns to trust the process. High-intensity exercises are different. Sprinting, HIIT, jumping rope to the limit, or any activity that leaves you breathless relies more heavily on glycogen. When glycogen has been partially depleted due to fasting, initial performance can be affected. That doesn't mean it's impossible. It just means adaptation takes time. Some studies show that after a few weeks of metabolic adaptation, people can maintain high-intensity performance even with lower glycogen stores. But rushing things is where the problems begin. This is cutting-edge information that most fitness content overlooks. Timing your exercise on an empty stomach is crucial for optimizing your circadian rhythm. Your body's internal clock influences hormone production, body temperature, and metabolic efficiency throughout the day. Exercising in the morning on an empty stomach, especially between 6 and 9 a.m., perfectly aligns with your natural cortisol rhythm. Cortisol naturally peaks in the morning to help you wake up and energize. Exercising during this time will amplify the beneficial effects while working in harmony with your biology rather than against it. This timing also optimizes melatonin production later in the day. Exposure to morning light, combined with exercise on an empty stomach, helps regulate the sleep-wake cycle, improving sleep quality and recovery. Better sleep means better hormone production, creating a positive feedback loop that amplifies all the benefits we've discussed. One of the most important things to keep in mind when exercising while fasting is maintaining electrolyte balance. As insulin levels drop during fasting, the kidneys excrete excess sodium and water. This is normal and beneficial, but it means you need to replenish essential minerals. Add a small amount of high-quality sea salt to your drinking water while exercising during a fast. This salt provides sodium and trace minerals that support the heart's electrical system and prevent headaches, a common problem for many people during their first few fasting workouts. Magnesium is especially important. Your muscles, heart, and nervous system all depend on adequate magnesium levels. Consider supplementing with 200 to 400 milligrams of magnesium glycinate before workouts on an empty stomach to ensure optimal muscle function and prevent cramps. Your first workout on an empty stomach might be challenging, but that's normal. Your body is learning to function in a new way. Your liver is building up its enzyme system to efficiently produce ketones. Your muscles are learning to burn fat effectively. Your brain is adapting to using ketones as fuel. Most people find the second workout while fasting significantly easier than the first. By the third or fourth workout, many report feeling energized and alert throughout the entire session. This suggests that your metabolism has become more flexible. capable of efficiently switching between different energy sources. Patience is key. Don't judge the entire method based on your first try. Give your body 2 to 3 weeks to build the necessary metabolic processes to function effectively in a fasted state. What you do after a workout on an empty stomach is just as important as the workout itself. Your body has expended energy and activated recovery processes that need proper support to complete their tasks. End your fast with high-quality protein and healthy fats. Your muscles need amino acids to recover and grow stronger. Your liver needs building blocks to continue producing enzymes that help burn fat effectively. Avoid ending your fast with refined carbohydrates or processed foods, as these will cause insulin spikes and halt the fat-burning process you've worked so hard to activate. While exercising while fasting can be very effective, it's not suitable for everyone. If you are pregnant or breastfeeding, your body has higher nutritional needs, and this is not the time to experiment. If you have a history of eating disorders, exercising while fasting may reinforce unhealthy habits and should only be done under professional guidance. People with type 1 diabetes or anyone using insulin need to be especially cautious, as regulating blood sugar becomes much more complicated without food. Chronic kidney disease, severe underweight, or medications that must be taken with meals are also cases where exercising on an empty stomach may do more harm than good. Listen to your body during fasting workouts. Persistent dizziness, rapid heartbeat that doesn't subside after rest, confusion instead of alertness, severe weakness, or nausea are signals that you need to stop. These aren't proof of discipline. They are warning signs. Regular exercise on an empty stomach offers cumulative benefits that far outweigh individual workouts. The number and efficiency of mitochondria in the body increase. Insulin sensitivity improves. Fat burning becomes more natural instead of requiring strenuous effort. Many people find they have more consistent energy levels throughout the day, fewer cravings for processed foods, and better sleep quality. These aren't temporary changes. They are long-term improvements in your metabolic adaptability, accumulating gradually over months and years. Exercising while fasting isn't reckless, extreme, or only for elite athletes. It's an effective method when used with understanding and control. Your body isn't designed to require constant food to function. It's designed to adapt, convert energy sources, and protect what matters most when resources are limited. Exercising while fasting simply helps your metabolism rediscover how it works. It activates ancient survival mechanisms that make you stronger, more agile, and more resilient. The goal isn't to endure. The goal is to control. Control your energy levels, your metabolism, and the signals your body sends each day. When you understand the science behind exercising while fasting, you'll realize it's not about deprivation. It's about optimization. You're not starving your body. You're teaching it to tap into the enormous energy reserves it's long stored. You're not weakening yourself. You're becoming metabolically superior. So the real question is, some trainers claim you should never exercise on an empty stomach, while others argue that exercising while fasting is the only way to exercise properly. After hearing all the opinions, what do you think? Is exercising while fasting overrated, underrated, or simply misunderstood? Let me know in the comments. And if this helps you see your body in a different light, subscribe to the channel for more scientific insights into how your body actually works.